Hello everybody, today we are going to learn about pure rotational motion. Pure rotational motion is defined as a rotation about a fixed axis or point. Of course, the fixed point will have zero velocity and zero acceleration. Normally, the fixed point is shown as a hub or bearing so that you can easily see that the body having a pure rotational motion. How we can find the velocity for a pure rotational motion? The main thing is we need to understand that all the point rotating with pure rotational motion will has the same angular velocity and same angular acceleration. And the velocity and the angular velocity and the angular acceleration is in the axis in z axis or unit vector k. We also need to understand that the velocity of a pure rotational motion is always perpendicular to the radius of rotation and in the direction of rotation, meaning if the rotation is counterclockwise, then the velocity also pointing counterclockwise. We can find the magnitude of the velocity by using a scalar v equal to omega r. We can also find the velocity by using a vector equation given by omega k cross the radius in I and j unit vector. To use a vector equation, you must understand the rule of vector cross product. You need to remember the right hand rule formula. What about acceleration? The acceleration of a pure rotational motion consists of tangential acceleration and normal acceleration, at and an. Tangential always perpendicular to the radius of rotation and the normal component always pointing towards the point of rotation and the magnitude given by omega square r. If we are using a scalar and if we are using a vector formula, it's given by omega k cross bracket omega k cross ri and j component. To find the magnitude, we just use the theorem Pythagoras. Or we can just use a vector by combining the tangential and normal component.